right, so where did it go? Okay, good. All right, so, all right, tell me about psychology. What is psychology? Yes. Okay, the study of the science of the mind. All right, when in class, when I ask you these questions, like I want to hear like your interpretation, but also like you should feel free to look at your notes, right? I'm not like, it's okay. Day 2 of content for you to refer back to your notes. Okay, study of the mind, behavior and mental processes, right? So yeah.
Cognition.
All right, cognition. Good. So we're talking about those two things, right? Behavior and mental processes. We finished last class talking a bit about some of the thoughts in psychology, right? The development of psychology. What are some of those developments? Early movements in psychology.
Structuralism, functionalism.
Let's start there. Structuralism. What is structuralism? What were they all about? All right, breaking it down to the basic elements, right? To try and understand the very basic structure of the mind. Okay, then we start talking about the functionalists. What are the functionalists all about? Function? A little bit more. All right, how the mind is functional, how it adapts, right? How it allows us to sort of adapt to the world that we are experiencing. What else? What's the next movement? Behaviorism. What's behaviorism all about? All right, observable behavior. Why? Why were behaviorists so interested in observable behavior? What's that?
I said because you can see it, but
Okay, you can see it. So what was their argument? What can you not see?
you can't see inside the brain.
Okay, you can't see inside the brains of people, right? So we should be focusing on those sort of overt behaviors that we can see people engaging in, right? What else? Let's take a step back. What are the 4 goals of psychology? What's that? Okay, description. Goal number 1, description. What are we going to do here? Okay, what is happening here, right? So simply describing what it is that's going on here, right? What's the second goal? Explanation. So what are we doing here? All right, why? Explaining why it is happening. The third goal? Prediction. When, under what circumstances is it going to happen? And finally, what's our fourth goal? Control. Okay, so how can we control this particular behavior? So can anybody give me a situation utilizing these 4 things? This is, I know. Sort of day 2 content-wise. Miles, you got something? Yeah, give me a scenario using the 4 of those.
Testing on rats and stuff like that.
Okay.
With the hypothesis, then the thing.
All right, train them to get to the maze and stuff?
I don't know if this is necessarily what you wanted, but like, say for example, if somebody is like super, say they express mania, where they go from extreme highs to extreme lows, you would think that they would have bipolar,
Okay.
and then you could try and go from there.
Okay.
Try and see
Okay. All right. So description of what is happening, explanation for why it is happening, predict under what conditions it's likely to happen, and control it. You got something as well?
Depression.
Depression? Okay. Good. All right. So what is going on? Explaining why it is happening, predict when it's likely to happen, and how can we control it. Good. All right. Very good. So we started talking last class about how it is that psychologists do what it is that we do, right? What does it mean to say that we are a science?
Has to be measurable.
All right, it has to be measurable. So what's the problem here that we face when it comes to science? What is science all about? Okay, something you can observe and see. This is where we left off, right? This is where we ended, right?
Yeah.
Okay, going into the scientific method. Right? So as a science, what we're doing is we are systematically gathering data. We're trying to reduce biases. So one of the big themes in social psychology, and we'll talk about with some other schools in psychology too, is the idea that there probably is some objective world that exists, but we see that world through our own biases, our own lens, our own framework, right? So do we see the world as it truly is in an objective fashion? No, right? We're seeing the world that we sort of want to see, right? This is one of the very big ideas in social psychology. If we utilize that to kind of think about the scientific method and how we gather data, what we need to do is sort of check our own biases, right? And see the world as it really is and not how we wish it to be or how we think it is, okay? So we're trying to reduce all of the biases that we're coming to the table with and reduce any error in measurement, right? Every science has tools they use in gathering information and gathering data, right? Measurements. Astronomy uses telescopes. Biology uses, amongst other things, uses microscopes, right? So what is it that psychologists use? And we'll talk about some of those tools that we can use here. Okay, so scientific method, right? System of gathering data, trying to reduce any sort of bias and error in measurement so that we're seeing things in an objective manner. So steps in the scientific method. One is that we perceive the question. What does this mean? What's that? Okay, it's based upon what? Say it again.
Like a problem that you have and you're sort of kind of trying to solve it.
Okay, so maybe a problem, we're trying to figure out how to solve it. Good. All right, let's take this scenario. Let's say that my kids, right, on Saturday mornings after watching a violent television show are always aggressive with one another, right? Punching each other, wrestling around, someone's always in and out crying. So I've noticed this after they watch these aggressive TV shows that this seems to be a pattern of behavior here. So what's the question I might start to perceive here?
Is what you watch on television like correlated with your actions afterwards?
Okay, and in particular here with this situation, what am I concerned about? What type of television are they watching? Violent television, right? So maybe I perceive this question. Does watching violent television cause people to be aggressive? Okay, so I've perceived this question. I start to form a hypothesis. Remember, a hypothesis is this tentative explanation we have for what is going on, right? Based on our observations, what do we think is going on here? So here I might form a hypothesis. Watching violent television causes kids to be aggressive or causes aggression in kids, right? So I have this sort of hypothesis that I'm going to test in step 3. So number 1 here, we are perceiving the question. 2, we form this hypothesis about why it is we're seeing this, right? A testable proposition. 3, we test the hypothesis, right? We run a research study to examine this idea. 4, we draw conclusions. This is the sort of data analysis that you're going to do. So if you're a psychology major, if you're a business major, a lot of you guys will end up taking like a SAS class, right? A data analytic class. Here's what we're doing. We're drawing conclusions. Based upon the data that I've gathered, can I make inferences? Can I make conclusions scientifically using my stats techniques about what it is that's going on? And in the realm of science, we publish our results. So we report our results so that other people can try to replicate what it is that we've done. Why is replication so important in the sciences? Yeah.
Because if you can replicate it, it's always going to be true.
Okay. Well, the more replications we have, the more confidence we have in this particular research finding, right? If all these studies over and over and over that are being done are showing that watching a lot of violent television or playing a lot of violent video games is causing increased aggression in children, it's giving us confidence that we are finding something that's real, right? That there is something there. Okay, so 1, perceive the question. Something in our environment has sort of caught our attention and we're thinking about it and want to know why we see these things. So step 2, we develop a hypothesis, something that can be directly tested. 3, we test it. We test that hypothesis. 4, we draw conclusions based upon our data analytic work about our study. Is our hypothesis confirmed? Do we need to reject the hypothesis? And then we report our results. In the academic world, we publish them in academic journals. We go to conferences. We tell, not necessarily the world, but we tell other researchers who are interested in this what it is we're doing, what it is that we are finding. Again, replication is incredibly important. Okay. It's important to keep in mind, though, that not all questions that people have can be scientifically or empirically investigated. So not everything is going to be able to be tested, right? So what is the meaning of life? Great as a sort of maybe philosophical discussion, but how would you test that in any sort of empirical sense, right? Some things just aren't testable. Beliefs that people have don't necessarily need proof, right? People who have faith in different things, that is belief in the absence of really evidence, right? So a lot of these questions that people have, we may not be able to test in a scientific sense. Scientists, though, we need proof, right? We are trying to objectively gather data. We're looking for proof for reasons why the things that we believe, whether they're supported or not, right? We're testing hypotheses, things that can be empirically tested. All right, so what is it? How do we sort of do the things that we do? Naturalistic observations. So we'll talk about some descriptive methods for gathering data. Naturalistic observations, we're going to watch animals or humans behave in this sort of natural environment, right? And every research design has advantages as well as disadvantages. So the major advantage of this naturalistic observation is that we're going to get a realistic picture of how people behave. We haven't created this sort of artificial environment. We've created a sort of natural environment to investigate how it is that we're seeing them in their natural environment. So we're investigating them in their natural environment, how they behave. Right? Somebody like whom? Who is this? Jane Goodall. What does Jane Goodall do? All right. She's embedded herself, right, in her work. She lives and works with the animals that she is researching. She's directly involved in watching them in their natural environment. So again, everything has disadvantages, right? What happens to people when they know that they're being observed? They act differently, right? They're going to change the way that they behave. So a lot of early industrial organizational psychologists were trying to figure out how they could increase productivity in people who worked in like factories and stuff, right? So that you produce more light bulbs or whatever. So they try various things. They would make the room a little dimmer, dim the lights a little bit. Let's make the lights a little brighter. Let's give people shorter breaks, but more frequent breaks. Let's give people longer breaks, but sort of less frequently. So instead of every 15 minutes, every 3 hours you get 15 minutes, now you get like 5 minutes every hour. All these things were increasing productivity, right? And they couldn't figure out why. But if somebody's walking around with a clipboard and checking off exactly how many things you've made this past hour, are you going to work your hardest? Yeah. When you know that somebody's watching you, you change the way that you behave. So how do we get around this? It's a massive limitation. How do we get around it? Yeah. Cameras, okay. So maybe, yeah, we could record people, see what they're doing. Okay. You know what just came to mind is like, have you seen the scenarios they'll set up? Undercover, yeah, somebody was talking about Undercover Boss earlier. Okay, so what does the Undercover Boss do?
The CEO of the company goes and pretends to be a worker to see how his workers are treated in like their workload and to see his company.
Okay, so this is good, right? What the CEO is doing is they're being a participant observer, right? So he or she is sort of watching what it is that the workers are doing, but they have joined the group, right? I've actually never seen the show, so I'm going to make some assumptions here, right? They join like they are a fellow worker. Okay, all right, so nobody knows that this is the CEO of the company I work for. They think that this is a fellow worker who has joined them in whatever it is that they're doing, right? All right, good. So here he or she's embedded themselves as a participant observer, right? So they become an actual participant in the group that they are studying. So 1950s, there's this doomsday cult that's becoming sort of concern for their predictions. Right? Social psychologist named Leon Festinger gets wind that this is going on, and he's pretty interested. Right? So here's this doomsday cult that thinks that a spaceship is coming to pick up the believers and whisk them off to, I presume, a better place. Nobody goes to a worse place, right? To a better place. All right. So he goes and he knocks on the door of the cult leader and says, my name is Leon Festinger. I am a social psychologist. I'm very interested in group behaviors. Can I study your group? What do you think she says? No. Shuts the door. So he's thinking about, now how can I get involved in this? So he sends 2 graduate students to knock on her door and tells them, what I want you to do is to tell her that you have received visions from aliens, telling you to come knock on the door, and you're not sure why. So they do. They knock on her door and say, we've been receiving visions from aliens to come and visit you, and we're not really sure why. What does she say? come on in. So now he's got 2 graduate students that are embedded in this group and watch how this sort of group dynamics of this group unfold. A book came out about it. I think it's called When Prophecy Fails. But they end up on this mountaintop waiting for the spaceship that never comes. It never comes. It never comes. So what happens to these groups when their prophecies fail? So that was one participant observation. Oh, I can give you another example. This is highly unethical. We'll talk about ethics at the end of this semester. The tea trade or the tea room studies that were done. Okay, so this guy was interested in who is involved in this tea trade activity. What it is men would meet in at the bathroom in a public park, and in groups of 3, where someone would watch the door and the other 2 would go into the bathroom and engage in sexual activity together. Okay, so this researcher is interested in who these guys are. Who is it that's participating in this practice? So he pretends to be a part of these activities. So his role is always going to be what? Watcher. I'll be the lookout, right? So he's the lookout. The other 2 guys are in the bathroom, and then he sorts of follows them to see who these guys are, right? What kind of lives do they lead? So he follows them, finds out a lot of information about what they do, sort of life they live. What do you think? What do you find out about these individuals?
They were normal, average people with families.
But normal average, what do you mean?
Husband, wife.
Okay, all right. So they had, they were self-identified heterosexual individuals, married, many of them, with children. Okay, so highly unethical what he did, and when these findings came out, they received a lot of attention. But great example of participant observation. He embedded himself within this group to study him. Same with Leon Festinger and his graduate students. One of the disadvantages that we see is this observer bias, where some observers might see exactly what it is that they expect to see. So, for instance, let's say that we have some medical researchers who have spent a large portion of their career developing this drug to help people with Alzheimer's disease. Okay? And observing the patients that are receiving their drugs, might they see signs that they're doing better? Maybe unintentionally, but might they look for any sign that would indicate these individuals are doing better? Right? They might see things that aren't sort of really there. So one way to combat this has been blind observers, where you have people doing the observing who don't really know what the question is or what the research involves. If they don't know, presumably they can't be biased in sort of their reporting of what they're seeing in these individuals. Each naturalistic setting is unique, and the observations that are sort of gathered in one specific incident may not hold across the board. So we may get a lot of information about this particular isolated incident, but not a lot that is generalizable to others. So that's some of the disadvantages. The other issue is we can do laboratory observation. We can watch animals or humans behave in some type of laboratory setting, right? We bring them into the lab and expose them to something. So this, the strange situation, looking at attachment in kids to their primary caregivers. What they'll do in the strange situation is they'll bring kids and mom into this room where there's some toys. The kid gets occupied, busy playing them, and the mom sneaks out of the room. Okay? They're watching through the two-way mirror, right? If you're in a psychology experiment, there's a mirror. There's probably somebody watching you. So mom comes around with the researchers and they watch the child. What's the child going to do eventually? Cry, right? When noticing that mom or whoever the primary caregiver is gone, they start to cry. Mom then enters the room and they see what the child's reaction is. Securely attached children, mom comes back in, they're easily soothed, everything is okay, right? For some of the other attachment styles, you may see things like they're not easily soothed. They continue to be upset. Or now they're just really pissed at mom, right? So they're swinging at her and stuff like that, right? But to create these situations, they have to bring them into the lab. The major advantage is we get control over the environment, right? The kids, the people that take part in this are only exposed to the things that we want them to be exposed to. If we have any sort of specialized equipment that we're using in these situations, we may need them to come in the lab. So a friend of mine at Texas Tech, over the last Super Bowl, they had students come in and they watched the Super Bowl on the big screen in the auditorium. And they hooked them up to physiological, they call them phys readings, physiological measurements. So they're measuring things like blood pressure, heart rate, galvanic skin response, right? So to see when, during the game or during particular commercials, people become sort of physiologically aroused in response to the game or what they're seeing there. So what Zach is interested in, he needs this sort of specialized equipment. Makes sense? You can't really do a naturalistic observation here. It doesn't make sense. But you can bring people into the lab and have them exposed to this sort of specialized equipment. Have you seen this? The Sky Bridge in Arizona over the Grand Canyon, right? So some of the other things that to do with kids is depth perception, right? At what point will they not walk off a clear edge when kids can start to figure out this depth perception that the tabletop ends there. If I go any further, I will fall over, that sort of thing. It still happens with us as adults, right? You know that you are going to be okay out on this bridge. But for many people, taking those steps out on that bridge is incredibly difficult. Has anybody been there? What'd you think?
It was crazy.
It's hard, right? Your mind's like playing tricks. Your body is clearly, and your mind are telling you, don't do it. Don't do it, right? We always have this push towards survival, and it's against our instincts when you're out there with nothing around you. It feels incredible, right? All right, but they do something with kids looking at depth perception, and it works on adults too. All right, so some of the disadvantages of the lab settings. It may result in artificial behavior, right? So we create these sort of false environments for people. Will they behave in different ways? So as a result of these artificial environments that we create, do they change their behavior? Are they not acting like they normally would in real life situations? So these descriptive methods can help lead to the formation of these testable hypotheses that we have. Case study. The case study technique is where we study one individual in great detail. We get a tremendous amount of information and detail about this one particular person. The disadvantage may be that it doesn't apply to other individuals. And the famous case here is Phineas Gage. What happened to Phineas Gage? Good.
Didn't they like completely remove his frontal lobe? Isn't that what happened?
It was severed from the rest of his brain. I don't think they removed it. Right. So he's working on the railroad, and there's a tapering iron that's shot through his face. It enters underneath his cheekbone, and it leaves out the top of his head. Incredibly, he lives. Right. So they document changes in him as a result of this injury. So in a case study, when we find out that somebody has received brain damage or something like that in a very specific part of their brain, what they'll do is they'll look at what this person is like or was like prior to the injury, and then what has happened to them after their injury. Do we see changes in this particular person? And incidents like this are terrible, right? But they are opportunities to learn a lot about what has happened to somebody, and perhaps what the function of that part of the brain is as a result of it being damaged, right? And Phineas's skull here, like the hole right in the top of his skull. Incredibly, he lived through that incident. All right. Surveys, right? We could give survey research out on whatever it is that we're interested in investigating in this particular project. So we may ask a series of questions. We may give participants statements and ask them to either disagree, strongly disagree, slightly disagree, a neutral, a slightly agree, strongly agree. Answer on that sort of Likert scale continuum. Who's taking a survey? What was it on? What were they looking at? Your opinions about what? What was the topic under investigation?
I feel like we do have to do one for Cal U every single fall.
Oh, like a climate survey? Like the.
I hope like a drug one's high school.
Okay, drug one in high school. What were they looking at?
If you like use drugs and you drink, how often, why you do it, something like that.
Okay, so the frequency of drug use, these sorts of things. Okay, so anything that we're sort of investigating, we can look at through this sort of survey idea. We need to make sure that we have a representative sample. Okay, we have a population that we'll be interested in. The entire group of people or animals for psychologists that we're sort of interested in learning more about. So let's say that I am interested in drinking behavior amongst California University freshmen. Right, there's something like 1,200 freshmen that enrolled this year, something like that. Yeah, doesn't matter. Let's say 1,200. All right, so we have 1,200 students who have enrolled. The freshman group, this freshman cohort, is the population that I'm interested in. Realistically, could I get all 1,200 to participate in my survey? No, right? Nor do I need that. If I'm able to get a representative sample, so a smaller number of people from this broader population that I'm interested in, I can use that for my data. Now, how I get that data may impact the representativeness of that particular sample. So what if I went around to all 8 a.m. classes Monday through Friday and surveyed freshman students and found out like these students aren't drinking at all? What might be the problem here? All right, they have class really early in the morning, so they're being responsible, okay? They're lying. All right, that is always a concern in survey research, right? Still drunk from the night before? All right, so maybe they're not representative of the entire freshman population, okay? If I want to be able to talk about an entire population, but I'm only getting some people from that population that I'm interested in, as long as that sample that I get is representative of the entire population, I can still continue to talk about the entire population, right? If they're not representative of the entire population, I don't have good data here. I can't make these sort of generalizations back to the population that I'm interested in. So with surveys, some of the advantages that we get data from a large number of people generally pretty quickly. So think about what my friend Zach was doing at Texas Tech with the physiological readings. So he's got to wait for big sporting events, right? And he's limited to however machines they have, right? What they use to gather physiological responses. So he can't get that much data very quickly. But surveys, we can sort of send them out pretty widely and get a large amount of data very fast. The other thing that's nice about surveys is maybe I'm interested in covert behaviors. Things that people may not in a face-to-face interview be willing to tell me, like frequency of risky sexual behaviors, frequency of drug use, right? So we're asking them in surveys, anonymous surveys, hoping that people are going to be much more honest with us in that particular mode of data collection rather than something like a face-to-face where it may be uncomfortable for people to admit these different things. Disadvantage, if we don't have that representative sample, then the results that we get, they're not going to be meaningful. And like Miles said, right, maybe they're going to lie to us. People aren't always accurate. So maybe I'm looking at things like prejudice, right? Or if we can see that in the past that people had engaged in discriminatory acts or behaviors. Do people know they shouldn't be prejudiced? Do they know they shouldn't be treating people differently because of their perception of what social group that they belong to? Yeah. Might they lie to make themselves look better? Of course, right? So that's always a concern that we have too, is that they're engaged in this sort of courtesy bias, where they're sort of presenting themselves falsely in a survey, making themselves look better. All right, so here's this visual, right? I have this entire population that I'm interested in. Freshmen at California University of Pennsylvania. I can't have everybody participate in my project, but that is okay. As long as I have an adequate sample, a sample that represents effectively the entire population, I can make inferences back, right? So as you progress, if you're a psychology major, you'll take inferential statistics, right? When I have this small data that represents the population, I can talk about the population as a whole. So looking at like the big things right now, right? We have Donald Trump that's leading in the Republican Party right now. Yes? You pay attention to politics at all? At least you know about Donald Trump? That much you know? So how do we know that he's leading? What do? We take a poll, right? So in this situation, in the Republican primary, what's the population that those polls are, who's the population that they're interested in? What? Republicans, members of the Republican Party. That's the population that they're interested in. Are they able to measure every single member of the Republican Party? No, right? Which is why they're reporting samples. And if you look at the sampling error, they'll give that to you usually at the bottom of the graphs, right? So they'll say something like Donald Trump has 37% of the support amongst Republicans in Iowa or whatever, right? And at the bottom, they say plus or minus 2 percentage points. What they're saying is we feel that we are accurate within plus or minus 2 percentage points. So it's somewhere for sure between 35% and 39%. Does that make sense? Right? They're not going to be able to get everybody. So they're going to get a sample, right? There's always going to be some error, which they're trying to show you in that plus or minus 2 percentage points. But as long as we have an accurate and representative sample, we're able to make inferences back to the population as a whole. Who's seen this? What happened here?
The newspaper came out
Yeah.
But it was wrong.
It was wrong. Yeah. So what happened here? Do you know?
He thought that he was gonna actually become president because of all the polls that were taken. They were all pointing towards him, saying that he was gonna win, but then he ended up losing.
All right. So what happened with all these polls? What was the problem here? The problem was the people that were in their sample were not representative of the general population as a whole. Okay? So they had a sort of a sample that wasn't representative of the voting population as a whole. Their small sample they had was sort of skewed. It was a group of individuals that were highly supportive of Dewey, candidate Dewey. So much so, overwhelmingly so, that the newspaper thought Dewey's going to smoke Truman in this election. We can call it an early night and all go home, right? Bad science, bad data. They relied on an unrepresentative sample to make an inference back to an entire population that was wrong. And they have this embarrassing photo. If that paper's still around, most newspapers have folded. But if that one's still around, they have this embarrassing photo to highlight their bad science knowledge. Okay. What's a correlation? Who's heard the term correlation? Anybody have stats in high school? What's a correlation?
It's like a group of data that sort of kind of follows like a slope of a line. Like the points sort of kind of go together, but they're not all exactly the same.
Okay, if you were to plot it out, yes. Okay, all right. I'll show you the plot to get what you're looking at. Yeah.
Two sets of data that are related to each other.
Okay. Two variables that we have. Usually we have some data that shows that they're related to one another. All a correlation tells us is that there is a relationship that exists between these two variables. What does correlation not tell us? Causation, right? Correlation is not causation. So when we're looking at correlation, we're simply looking at the relationship that exists between variables. And a variable is anything that can change or vary. So we could talk about self-esteem. Self-esteem and its relationship to academic performance, let's say, right? We could talk about political conservatism. We could talk about scores on a particular test. They're going to vary. We could talk about temperatures in a room. All these things are going to vary to some extent. And all these things represent variables, things that we can start to look at in our sort of correlation analysis. So a measure of how these two things go together. In the number that you get for a correlation, it's going to range from -1 to +1. -1 is a perfect negative correlation, and +1 is a perfect positive correlation. But the number that we get tells us a couple things about this relationship. It tells us the direction of the relationship, and it tells us the strength of the relationship. If I know the value of one variable here, it allows me to make a prediction about the other variable. But I'm not able to talk about causation. So let's say if I know as a student, if I know your self-esteem level, I'm able to some extent to make a prediction about your academic performance. Right? I can't say, though, that your high self-esteem is causing you to do better in school, or that your low self-esteem is causing you to do poorer in school, right? I just know that this relationship exists. I can make a prediction. When your self-esteem is high, you're doing well in school. But there's always the issue that it might be a sort of, there's two explanations here, right? That you are doing well because of your high self-esteem, or that you feel really good about yourself because of how well you are doing in school. You see the difference? There it's self-esteem that's causing you to be performing well at school. And the other one is your good performance in school that's causing you to have a higher self-esteem. When we know correlations, all we know is that this relationship exists between these two variables, but we don't know what it is. All right. So correlation values range from -1 to +1. A value of 0 indicates that there is no relationship that exists between these two variables. -1 is a perfect negative correlation, and +1 is a perfect positive correlation. So in a positive correlation, these variables are going to be related to one another in the same direction. And what that means is, as one variable goes up, so does the other. As one variable goes down, so does the other, like self-esteem and academic performance. They're strongly correlated positively with one another. So they rise together and they fall together. In a negative correlation, they move in opposite directions. So as one goes up, the other goes down. As the other goes up, the other goes down. Right? They're always moving opposite of one another. So positive correlations, they rise together, they fall together. negative correlations move opposite of one another. So maybe depression in academic performance. Greater depression associated with less, not doing that well in school. Alcohol consumption over the course of the semester and your GPA, right? But again, this sort of correlation knowledge doesn't give us the ability to infer causation. So is somebody drinking a lot because they're doing poorly in school, or are they doing poorly in school because they're drinking a lot? Did I say that the two ways? Okay, all right. Okay, yeah, that makes sense. All right, so when we know it's correlation, what we don't know is the sort of causation here. Let's say correlations tell us the strength of the relationship between the two variables and the direction, okay? So a correlation of negative 0.25 and positive 0.25. Which is a stronger correlation here? That strength is exactly the same, okay? Negative 0.25 and positive 0.25, the strength of that correlation is exactly the same. What's different is the direction, okay? Does that make sense? Negative, they move opposite one another. Positive, they rise together and they fall together. A correlation of 0.89 is much stronger than a correlation of 0.25. You with me? But that sort of negative 0.25, positive 0.25, that strength of that relationship is exactly the same. Okay, so when we see correlation values, it tells us a couple things. It tells us the direction of the relationship that exists between these variables, and it also tells us how strong that relationship is. The closer we are to positive 1 and the closer we are to negative 1, the stronger that relationship is. The closer we come to 0 on either side, the weaker that relationship is. You with me? All right. Correlation does not prove anything about causation, though. And the classic example they give is ice cream consumption and murder rates in a city. Two variables that are highly correlated with one another. So what's going on here? Do we eat a little ice cream and go commit murders? Or do we get some ice cream after we've committed a murder? Yeah. All right, they both happen more frequently during the summer, right? They're explained through a third variable. They're explained through heat, right? But so it doesn't make sense to think about it in that particular way, that they would cause one another like that. We simply know with a correlation that a relationship exists between these variables. So here's the line issue we were getting to, right? The first one, this graph is a perfect positive correlation. They're moving up completely in unison with one another. In this sort of real world of data collection, you're not going to see this. You're going to see something that looks more like this, right? Where when we plot the data, we say a sort of general trend upwards. So things like self-esteem and academic performance. As self-esteem is going up, it's associated with an increase in academic performance. You with me? Can't say cause here. Can't say cause because all we have are correlations. This one, there is no correlation. The data is kind of all over the place. We don't really see a general trend here. In the bottom, your bottom left, you see a perfect negative correlation. They're moving down, right? So as one variable is going up, x is going up, y is going down. Again, in a real world of data collection, you're never going to see your data plot this nicely, right? You're going to see something that's more like this, where you see this general trend and a negative correlation. You with me? All right. So let's do this. You tell me here. A study of married couples showed that the longer they had been married, the more similar their opinions on social and political issues were. Is this a positive or negative correlation? Positive. How do you know? What?
More similar.
And? All right, longevity of the marriage, right? So more similar is associated with longer marriage together. So we have two possible explanations here. What are those explanations?
The longer they've been together, the more similar their thoughts become.
Okay, so over time, the longer we're together, the more similar we become over time. Or, what's the other explanation? Yeah.
They were together for a long time because they had some.
Okay, good. So they married somebody who was very similar to them, and that's really why they've been together for so long, right? Okay, so we see this correlation, but what we don't know is causation. So there's always this possibility that it's X causing Y or Y causing X. It's our similarity causing our marital longevity, or our marital longevity, because we've been around each other for so long, we're becoming more and more alike. So it does beg the question, do birds of a feather flock together, or do opposites attract? What is it? It's one of those, much more common than the other. Birds of a feather. Right? Birds of a feather flock together. We all know that couple. You're like, what? Like, how did this happen? You guys are completely different. But for the most part, right, people like people that are like them. Okay, so let's do another one. In a study of American cities, a relationship was found between the number of violent crimes and the number of stores selling violence depicting pornography. So let's say that it's a greater violent crime, more selling of violence depicting pornography. Positive, right? They're going up with one another. So as violence rate in the city is going up, we see it associated with increase in violence depicting pornography. So again, if all we know is a correlation, it leaves open two possible explanations. What's going on here? What's one possible explanation?
Because they watch so much violent pornography, the rate of crime goes up.
Okay, so all this violent pornography that people are consuming is causing them to be more violent generally. Okay, good. Or what's the other way around? Okay, so being more violent is causing them to watch more violence depicting pornography, right? When all we know is the correlation, this is how we talk about these things, right? We don't know the cause and effect link here. One more. A college professor found that the more class absences students have, the lower the grade in the course tends to be. Positive or negative? Negative. In what way? How do you know? Okay, very good. So the number of classes is associated with a decrease in academic performance. Okay, so we know this relationship, this negative relationship, but what does it mean for explanatory possibilities here? What's one explanation for what's happening here?
The more absences, the lower the grade is.
Okay, the more absences, the lower the grade is. Good, Miles?
The lower grade, the less reason they see to come to class.
All right, very good. So here we go, right? We have these two clear explanations. I'm missing class, I'm missing the course material, I'm not doing very well. Or I'm not doing well, I'm done. I'm leaving, I'm walking away, right? When all we know is the correlation, we can't make inferences back to something like causation. If I want to know what the cause and effect relationship is between two variables, I need to run an experiment. An experiment has a couple of key components. Okay? All right, but in an experiment, we are manipulating a variable. There is something that is directly under the control of the researcher. We manipulate it and see if there's a corresponding change in behavior that follows. Right? That sort of control over what is going on, where we manipulate the things that participants in our project are exposed to. That's the independent variable. Does it impact something else? Right? That cause and effect. Okay? We need to define what we mean a lot of times in our research. How is it that we are measuring something directly in our projects? This is the operational definition. So if I'm talking about aggression, I need to talk about very specifically what I mean when I say that I measured aggression in this particular study. So we'll go back to the TV example, right? So here in the classic study, they had kids with Bobo dolls. What's a Bobo doll?
It was a stuffed doll they can use to play with all the time.
Kind of.
Isn't it like that clown punching bag thing?
Yeah, it's weighted at the bottom, right? So the clown punching ball thing, it's weighted at the bottom, which is nice because you hit it, it doesn't fly across the room, and you have to chase it to punch it again. A kid punches it, and what does it do? It comes right back up, right? So this is great to calculate the number of times the kid punches the Bobo doll. So in these original studies, sort of investigating the link between violent television and aggression in kids, that's how we are sort of operationally defining aggression. In this study, what I mean is the number of times a kid punches the Bobo doll. Okay, so maybe you are a school psychologist and you are concerned about aggression that's taking place in your high school that you're responsible for. You could measure aggression in a couple ways. How could you measure it?
By the number of fights there are.
Okay, the number of physical fights that break out, but is aggression always just physical? What else could be going on? All right, so verbal arguments. So maybe here I have a couple different types of aggression. I could look at just all of the physical fights that occur on campus, but I could also look at the sort of verbal aggression that takes place on a high school campus as well. Make sense? So when we're talking about the variables that we are working on in our project, we have to be clear about our operational definition. When I say violence in these kids, what am I talking about? I'm talking about the number of times they punch the Bobo doll. You with me? All right. So the independent variable in a experimental design is what is directly manipulated by the researchers. So if I'm interested in studying the effects of violent television on aggression in kids, the type of television that I'm going to expose the kids to in my study is going to be my independent variable. Some of the kids are going to watch violent television. Some of the kids are going to watch non-violent television. Okay, so I have two conditions here. I have an experimental condition where they're going to watch violent television, and I have a control condition where they're not going to watch any sort of violent television. The dependent variable is what I think is going to be impacted by my manipulation. So again, I'm looking at the effects of a specific type of television consumption on corresponding behaviors of aggression. What I'm going to manipulate is the television. And what I think will be impacted is the aggressive acts that the kids engage in. This is the dependent variable, okay? What I think is going to be impacted by my manipulation. So we have the independent variable, what is under my control is the researcher, and the dependent variable, what I think is going to be impacted by this manipulation. The experimental group are all the participants in my experiment who are going to be sort of exposed to the independent variable. For here, they're the group that watches the violent television. My control group are all the participants who are not going to receive the sort of treatment here, right? So they are going to watch no television and do like some friendly play, or they're going to watch some non-violent television of some kind. Okay, so if I have all of these kids, right? I've got these kids who are going to take part in this study. Some of them are going to watch violent television. Some of them are going to watch non-violent television. Why should I not let the kids self-select into what a group they want to take a part in this particular project? Yeah.
Because then you don't get to control your group.
All right, good. Okay, good. So I'm losing control in this particular situation, right? If I let kids self-select, what might all the violent kids do, or the naturally more aggressive kids? What might they be drawn to? I'm watching the violence, right? And what about my sort of less aggressive kids? They might say, yeah, I'll watch Barney. Yeah, there you go. There's something that's like as non-violent as you can get, right? I'm going to watch Barney for a half an hour. And after the end, we say, well, look, these kids that watch the violent aggression are more that watch the violent television are more aggressive afterwards. Is anybody going to care? It doesn't make sense, right? I've lost control of this situation. So what do? What do you suggest I do here to maintain control over what is happening? I need to make it random, right? This is the third sort of key variable in experiment. So we have the independent variable, the dependent variable, and this random assignment. By chance alone, these kids are going to end up in one of these two groups. They're going to, by chance alone, they're going to end up in the violent television condition. By chance alone, they're going to end up in the non-violent television condition. This controls for any sort of confounding variable that might sort of impact what is going on here, like sort of naturally aggressive tendencies that existed in these kids, something like this, right? That would influence and bias, serve as a biasing factor in the results that I get at the end of the study. Yeah?
Is it like a group thing or like everyone's individually watching it?
Here, it could be either, however you wanted to set it up.
Because I was going to say that doesn't it make more sense to have like the violent people watch like and the less violent ones watch like some of their just like if it changes how they are.
So the problem is, with that example, what you would see is the groups aren't equivalent, right? Our experimental group and our control group aren't equivalent because there's some underlying factor that differentiates them right at the beginning. So if I see differences that exist between them, that's problematic. The goal of random assignment is that these groups are exactly the same. It's by chance alone that these kids end up in either of these conditions. So when I go to count the number of times they've hit the Bobo doll, the only way that these kids differ is in their exposure to violent or non-violent television. But for like a meaningful research design, I want those groups to be as similar as possible. So the only way they differ is with my manipulation. Okay? So random assignment, right? We have kids, by chance alone, ending up in one of these two conditions, right? All right, so what happens is we've created two groups that are similar. All the sort of individual differences that exist between these kids have been randomly dispersed between these two groups. What it means is we can now test for differences. Are we going to see levels of aggression that are different between these two groups? If I was to let people sort of self-select into these particular groups, right? So I've got all the emotionally confused kids, I don't know, in the experimental group, and all the village idiots in the control group, right? Right. So what happens is I have two groups here that they're sort of not similar right off the bat, right? There are some very clear differences that exist between these two groups. So if I do find differences between them, can I say that it's because of my manipulation, right? No, there may be some underlying factor that already means that these two groups are different from one another, right? The sort of mood that exists between these kids. What I want to do is through this randomization, this random assignment of kids into conditions, I get sort of the moods of kids dispersed across these two conditions. Right? So some of my emotionally confused people are in the experimental group, some are in the control group, some village idiots in the experimental group, some in the control group, right? So now I've got them randomly dispersed throughout these two groups. So again, what I have now is the ability to say that these groups were as equivalent as possible. The only way they differed is in the manipulation, their exposure to violent or nonviolent television. So if I see differences at the end of this experiment in aggressive acts, I can say the type of television that they were exposed to here, violent television, caused more aggression in kids. All right, some of the other issues that we may see, does that make sense? Any questions? Some of the other issues that you see with a lot with research would be things like the placebo effect, where the expectations of the participants in a particular study can influence their behavior. So when they're led to believe that they're receiving a drug or that they're receiving some type of special treatment, their behavior changes, right? Who's heard of the placebo effect before, right? In the context of what? Medication. People think that they're receiving some type of medication and they start showing signs of improvement, right? Even though they might not be. So how do we combat this sort of thing? Single blind study, where subjects don't know which group that they're in. So they don't know if they're receiving the sort of placebo or the sugar pill, or whether they are actually receiving the drug, right? So they don't know which group that they are in. Experimenter effect, talked a little bit about this already, right? The tendency for the experimenters' expectations for a study to sort of maybe unintentionally influence the study itself. So they're starting to see exactly what it is that they wanted to see come out of this particular study. So in a double-blind study, what we're trying to do is eliminate all of these biases, right? So the experimenter doesn't know if this person is receiving the actual drug or the sugar pill, the placebo, and neither does the subject or the participant, right? They don't know. So we're trying to reduce the placebo effect and the experimenter effect here. In quasi-experimental designs, these designs are not considered true experiments because we don't have the ability to sort of randomly assign participants to conditions or groups, right? So let's say that as a developmental psychologist, age is something that I am interested in. Is age something that I can manipulate? No, right? I can't. That's not something that we can manipulate. I can't randomly assign some of you to be 20 and some of you to be 80, right? It's just not possible. So in a quasi or quasi-experimental design, what we would do is look at the two groups, right? Test for differences, but keep in mind that we can't talk about causal factors necessarily here, right? One of the big limitations is that we can't randomly assign people to things. Or if I'm interested in gender differences, right? I can't randomly assign people to identify as a man and some to identify as a woman. People come to you sort of as they are, right? You can't randomly assign them to those conditions. We can still look at some of the differences that exist between the groups, but we can't talk about them in sort of causal language. All right, so example of a real experiment. Let's say my hypothesis here is that extrinsic rewards are going to reduce creativity, right? So what I mean is, why do people enjoy being creative? Why do you think a lot of, what's that? Expression, right? Being creative in and of itself is rewarding.
I was gonna say
Show their uniqueness, right? They're getting some type of internal satisfaction, internal reward out of being creative. So what's an external reward then? Yeah.
Like, I'll pay you $100 to paint this picture.
Okay. All right. So yeah.
Winning a prize for best coloring contest.
All right, winning a prize, something like this, right? So now I'm providing you with some sort of external reward for engaging the creative process. Right? So think about what we're talking about here is maybe the second album by a band that you like. The first one is so good. What's happened with the second one that comes out and you're like, this sucks. What's happened to those band members?
They've been paid by,
Right? They're not doing it for themselves anymore?
I was gonna say they've been paid by the company, so they change the sound of what pop culture wants them to sound.
All right, so maybe the record label is trying to change them in some particular way. They're struggling writing the next batch of songs. The first songs they put out, that first album, they did it sort of because that's what they wanted to do. The creative process was in and of itself rewarding. Now they're being paid to sort of be creative, right? A lot of people start struggling in this sort of scenario. Okay, so my hypothesis then is that extrinsic reward would reduce creativity. So now we have maybe two different sets of instructions that we're going to give to kids, and the dependent variable that we're going to measure here is level of creativity in this art project that they have. So we're going to have these judges rate how creative they think the various projects are. For our experimental group, they are instructed to make a project to compete for an award, a prize, right? The second group, the control group, is going to be told that they're going to make this project for fun. And that prizes would be raffled off, right? So what do we see differently between these two groups? Competition, or it's something fun, right? So here, whoever is the most creative, you are going to get the prize. Here, we're doing this thing for fun, and we're going to raffle prizes off. So it doesn't really matter what you create because it's going to be raffled off for fun. The results here supported the hypothesis. Those kids who were competing for the external reward were less creative. All judges rated these things. They were viewed as less creative, right? So setting up this research design to test a very basic idea that if I extrinsically reward you for something that you enjoy doing for intrinsic reasons, your satisfaction here and your ability to be creative is going to change. Does that make sense? So an interesting way that they designed the study to look for this. So we started talking about ethics earlier, right? What psychologists can and can't do. We have ethics committees, right? Groups of psychologists or other professionals who are going to look over all of the research that's proposed at like a university. And they're going to judge the sort of application to conduct this research, okay? And give it a seal of approval or denial. Here they're called IRBs. Most universities are called IRBs, or the Committee for the Protection of Human Subjects, something like this. There's a group of people who sit on this committee, and anybody at the university, any faculty member who's going to conduct research, has to put together an application and give it to this committee and say, is this okay for me to do at this university? They review it and either say yes or no, right? You simply cannot go out and conduct a study because you want to. Everything you do as a sort of member of this community has to be approved by other community members, right? Psychologists did some things that were not very nice, right? And it's to prevent those things from ever happening again. It wasn't just psychologists. The medical community has also done some very unethical things as well. Not treating particular people when they know that they have a disease. There was medical professionals, I think in Alabama, but I'll have to double check on this, who did not treat African Americans for syphilis because they wanted to see what would happen to the disease if they just let it progress, right? These people were led to believe that they were receiving treatment. They weren't. And when that became public knowledge that they had done this, people obviously were incredibly upset about what has happened. So these sorts of ethics committees that are implemented to make sure that people are not engaging in these sort of unethical behaviors. So how do they judge this research? How do they determine if it's something that can be done or if it's something that should not be done? At all times, the participants' rights and well-being must be weighed against the sort of study's value to science, right? If you're putting people in a sort of stressful situation, can you justify why it is you're doing that, right? So is it valuable to science to sort of, or do these rights of these individuals outweigh whatever it is that you would gain from this study? Participants must be allowed to make an informed decision about participation. So if you're going to participate in a study, you will get informed consent, where it tells you what it is that they're studying, and you sign off and say, yes, this is what I'm going to, I willingly participate in this project. Deception must be justified. if we are going to lie to you about what it is that we are doing in this study, it has to be completely justifiable, meaning that if you knew the true intention of the study, you would behave differently. You would behave in an unnatural way. It would ruin the study. That makes sense? So in some situations, if we're going to have to deceive you, we have to sort of justify why it is we're doing that. And you, as a participant in any psychological study, you have the ability to withdraw at any time. So at any point in time, if you feel uncomfortable that you don't want to participate in this anymore, you walk away. So participants must be protected from risks, or told explicitly that there are risks inherent with the participation in this particular study. And after you have participated in the study, we must debrief you. So if you have been deceived in some particular way, you've been lied to, here you are supposed to be told, we lied to you, this is what we were actually studying. Had we not lied to you and told you the truth, this would not have been a good study. We wouldn't have obtained the data that we wanted to. And any data must remain confidential. Your name is never attached to anything that you participate in at this particular project. All right, we can't foresee every problem in a study. So if at any time a researcher notices that the participant is having a difficult time, there's something going on here, there's a negative consequence that they didn't see, they are responsible for sort of removing this, right? Detecting and removing all unforeseen problems that might arise out of these studies. Animal research also comes with a set of guidelines as well. So why are animals used in a lot of research? A lot of times we study questions that can't be answered if we use human subjects. So we're using animals to help in those particular cases. With animals, the ethics committee is all about looking at making sure that we are not exposing animals to any unnecessary pain or suffering. Right? So there's not, everything is done for a very specific reason, that nobody is using animals just to use them, right? Everything that they're being exposed to is for a particular purpose. And if you look at the frequency with which animals are used, it's actually about 7% of psychological studies involve animals in some way. These rats, so like in this picture here, right? These rats are part of a drug testing study. Their bodies are enclosed in metal cases to prevent them from moving around during a test. What might you do as a researcher to help make sure that these animals are treated ethically? What might you do? Yeah.
Make sure they get fed.
Okay, make sure they're fed appropriately. Yeah.
After testing, let them run.
Okay, after testing, they're removed out of these devices that are constraining them in some particular way, that they're able to run around. Good. Anything else? Yeah.
You would make sure where their body is, if the cage is big enough to fit the animal, so it's not like,
Constricting them in some particular way.
yeah.
Okay, so that the cage that they are kept in is sufficiently large enough that they're able to move around within there. Good. All right. So all these steps need to be taken to make sure that we are treating animals appropriately. So critical thinking, right? A goal that I have in every class I teach is to make sure that you are becoming a more critical thinker, that you are able to make reasoned judgments about the claims that people make, right? So here we go. 4 basic criteria that you should keep in mind when it comes to critical thinking. There are very few truths that do not need to be subject to testing. There's a lot of ideas that are untested that people hold. Everything that can be tested should be tested. All evidence is not equal in quality. What's wrong with Wikipedia?
Anyone can go in and change it.
All right, Wikipedia is open source, right? Anybody can go in and change Wikipedia. You see why that's bad, yes? Yes? Who was it? I think Sarah Palin kind of told incorrectly the story of Paul Revere. And it was the first time Wikipedia had to freeze a page. People went into Wikipedia to change the story of Paul Revere to coincide with her incorrect telling of the Paul Revere story, right? This is what we're talking about when not all evidence is equal in quality. This open source, people can put whatever they want on there, right? Okay, so keeping in mind where the data is coming from, where this sort of evidence is coming from, and making sure that we're giving priority to that is really good evidence. Just because someone is considered to be an authority or have a lot of expertise does not make everything that person claims automatically true. Right? We need to make sure that whoever we are obtaining our information from, that they don't have an agenda, that we are hearing things as we want to hear them. Critical thinking requires an open mind. Right? We need to sort of always be open to new ideas and new experiences, but also being willing to look for information and evidence that either supports the claims that we hear or information and evidence that suggests these claims that we hear are not accurate. Questions? So Thursday we'll start talking about biology, biopsych stuff.